Miss Maggie here, and today we're going to talk about what is science. So this kind of goes for all of our sciences, and what I wanted to talk to you about today is what is the definition of science, my definition, and the scientific method, which most of you are probably pretty familiar with because I think it's been kind of drilled into your head forever. So I don't want to take a lot of time with this. Just to kind of go over what I want you to know for it. I'm sure that you've heard it ad nauseum, so I don't want to waste a lot of time with it. But just to make sure that we're on the same page where we're coming from, and then to kind of give you a little background about kind of the history of science, how it came about, and why I'm such a geek for it. So, today, what is science? So it is the study of the natural world around us. And one of the things that I always got when I was teaching, I would get a lot of people who came in and they would walk into my classroom. They had that angst first day. Oh my God, it's the worst thing ever coming in this science class. And actually, from the very get-go, everyone is a scientist. And so it broke my little heart to have people come in and be like, ooh, this is terrible. You're born a natural scientist. There is nothing about the natural world that as a human being, from the moment you take your first breath, that you are not exploring. It's in our DNA. That's the thing that babies want to do. They want to know what's going on around them. Think of how you're walking down the hallway as you're going to school, you're driving. How many rubberneckers do you see when something happens on the side of the road? We are curious beings. It's just in our nature. And that is what science is all about. It is the urge to explore the natural world around us. Only when we do it in science, we're doing it in a very controlled way. We want to organize the information that we get, and we want to be able to use it and share it with other people. So our definition for science is it's the study of the natural environment in a systematic way. So if you're keeping a notebook, I'm going to write it down for you so that you have it. It is the study of the natural environment in a systematic way. And that systematic way is what's important for us here in science. So, I'm going to choose, I don't like red. Let's try black. See how that shows up. No, blue. I like blue better. Oh, and all these people doing PowerPoints, I'm not very good at them yet. And also, I'm a big believer in actually writing things down. There's a whole theory on hearing, seeing, and writing. Those three modalities, when you do all three, hearing, seeing, and actually manually writing, you know, it's terrible, that having those three modalities actually helps you get that information and maintain it better. So, the systematic study of the natural world. And how do we do this in science? What makes this different than doing this in any other kind of study that you're doing in school? What do we use? I'm sure that you know that we do this differently than when we're studying an English class or we're studying in history. You can use it everywhere. It's actually really useful. We use the scientific method. And that is actually very helpful when you are when you're kind of doing any problem. And this is one of the reasons that I went back and decided that I would go back to school to get my teaching degree, is so that I could share kind of this knowledge, because it's a great way for people to use this sort of thinking tool to, like in their everyday life, to attack problems and situations and kind of come to informed decisions. So it works outside of the four walls of a classroom if you use this same sort of thinking. So maybe it's just because I'm a geek, but it really does work. So, scientific method. Ad nauseum, I'm sure you've heard it. And there are several different steps, so you can see this in different ways, but it basically is encompassed. There's probably 100 different ways that you've seen it, but no matter how it goes together, it's going to be basically the same. So you may have seen it written in different steps, but these are the steps I'm going to give you. So first of all, we're going to state the problem. So we're not just going to willy-nilly just study anything when we're in science. We have to actually have a stated problem. There's something very specific that we want to look at. So we want to narrow down what we're studying. There could be a million different variables going on in what we're studying, but because we want to be very specific, systematically studying what's going on, we're going to pick that one thing, because as you know, we only want to study one variable at a time. That way we have our control and then we have our experimental variable. So we need to know what that specific problem is that we're looking at. So we state the problem, then we're going to collect our observations. That's the fun part. So all of your observations, this is where you're going to get data, this is where you're going to, it could be visual data, it could be actually, timing things, whatever it is. And this is where, when I say that you can use this in real life situations, when you're figuring things out, this is important, collecting your observations and not becoming part of the situation. So you're having your control part, and that's the thing that's going to stay the same, and you only want to be watching the other part, the experimental part. So this is very much that systematic study that we have going on. Then, once we have our data, you're going to search for scientific laws. Usually, this is where you're looking for a mathematical correlation between what is going on. So we want to know what is happening here. Sorry, threw that math in there too early. I know, math, but this is where it works for us. So those scientific laws, you're looking for something that has already been talked about. Do these laws fit in here? What is it that's going to try to explain these observations that we have going on? And then that's where we're going to form the hypothesis for what we have our observations going on. So this is that best guess we've talked about. So this is our best guess for what we've observed. So, and this can go on as we collect more. You have your hypothesis, then you gather more observations, you're testing, seeing how it's going with this law that you found, and going back and forth. Then, as you gather more and more and more information, you're going to form theories. These are the big guys. So these theories are where you're getting more and more of these scientific laws working together with these hypotheses. You're building more and more into it. So we're getting more information. We're getting more of this working with the ongoing hypothesis. It keeps building and building. So these are just building up as we're getting more and more information, and you're getting more and more puzzle pieces added in, and it's continually building and building, and you're getting more and more data. And this is where you get your theories. So I think the most important thing about the scientific method is that these are never set in stone. So if something comes along from all of this up here that says, ooh, doesn't fit, you know, I have something that completely tweaks this, it's not working with this theory that I have going, we modify our theories. Those theories, it's not, there's never anything that is set in stone in science. If we had things that were set in stone, we would still be back believing that atoms were made of solid pieces. We would never have learned about the ability to split atoms and nuclear power. We would never have realized that the sun is in the middle of our solar system. In fact, we would believe that the sun was the middle of the universe. We'd never have learned to fly. Airplanes wouldn't exist. Cars wouldn't exist. The wheel wouldn't exist. So the fact that we can modify our theories when we get new information is incredibly important to scientific method, the whole idea of how science has progressed. Which brings me to the last bit that we're going to talk about. I just wanted to point out that when we talk about science and when I do my plan, we're going to start with physics because that's what I'm teaching my daughter first. And then chemistry, and then earth science, and then if I'm feeling brave, biology. What we're going to be doing is these things have been broken down into specific subject matters. And so when you're in class and you're walking from one class to another class to another class, you know, it's very nice. These are in compartmentalized rooms. You go from one room to another. But in reality, in life, that's just not how it works. Just like taking your English class carries over to your government class. English, you need it to do your lab reports in science class. Math is not, you know, just the class that you use in math class. If only. You have to use it in your science classes, and you end up using it to do the dates and times for history. Real life, everything is interconnected. So the same with science. I went through my little library and I pulled out, I have a chemistry book, one of many. We have an introductory course in physics. I have, what else did I bring? I have an earth science book, all very nice and neat. And I have a little biology review book for bio, where they have very nicely packaged them in very separate pieces. But in real life, you take biology, you have marine biology, that's going to be earth science and bio. You have biochem, right? You've mixed in chemistry with biology. You have, what do we have? We have physical chem, that's physics and chemistry. Then you have paleontology, that's earth science and bio. You have, there's all sorts of different ways that you can mix these things up. And while you have, you'll have the other thing that you'll have, especially when you get to college, professors who will say that one science is best. You'll have physics professors who claim that physics is the fundamental science, because without physics, nothing would move, or that's where quantum mechanics comes from and the Big Bang. But you'll have chemistry professors who will argue that without atoms, which are the fundamental things that make up chemistry, well, nothing would be here. Without biology, nobody would be here to study those things. And without, earth science and geology, we wouldn't have a place to be here to study it anyway. So, like I said, it is all intermingled, intertogether. So, science is, in my opinion, it's the best. But I totally understand if it's not your favorite subject. But I hope that you will join us and that we can help you get through it and make it a little bit easier for you to understand.